Now, if we started adding geometric sequences together, putting plus signs in there instead of commas, we would end up getting a geometric series. Remember, a series, you're adding terms together. Now, we have a couple of formulas that we can use to find the sum of a geometric series. Now, these first two up here are pretty much the same. If you go ahead and distribute through your first term here, you really get this one. So these top two are pretty much the exact same. Whichever one you choose to use doesn't make a difference. So for this first formula, you need to know your first term, you need to know R and the number of terms. For the second formula here, you still would need to know your first term, you'd still need to know R, but then that would be your last term. You can use either one, it does not make a difference. So let's go ahead and find our ge geometric series here, which means we got to add all these up, and we're doing that for our first 7 terms. Now, you might be wondering, well, this is subtracting and a series is adding. Remember that subtracting is adding the opposite, so it could be written out like this here. Now, your first term is what we have here. Remember to find R. We're not given R. You can take one term like a -8 divided by the previous term, and you get R to be 4. And we also have the number of terms that we're dealing with. So because I don't know my last term, which is a sub n, and we do know everything for this formula, I'm going to choose to use that top formula. So I'm going to plug in my first term. Then I'm going to plug in my R. I would encourage you to always put R in parentheses. It doesn't necessarily make a difference on the top if R is a positive number, but it does make a difference if R is a negative number. And then I'm going to plug in N. Now, for a geometric sequence, your exponent is always N minus 1. But you'll notice here, it's just the number of terms. So then you could work out the top, typing that into your calculator, hit enter, and then just hit divide and type in the bottom. If you wanted to do it all at once on your calculator, you'd want to go ahead and put the whole top in parentheses, then hit divide and put the whole bottom in parentheses. If you type in the top, you get this. If you type in the bottom, you get this. When you go ahead and divide these, you get negative 10,922. And we want to do the same thing on these next couple. You notice here we have our first term, we have R, we have N, so once again that's going to be this first formula. So all we have to do is just plug stuff in. Plug in your first term, plug in your R, plug in your N. And then all you have to do is just type that into your handy-dandy calculator. You can type it in all at once by putting the whole top in parentheses, divide, putting the whole bottom in parentheses, or you could type the top in, type the bottom in, and then divide. Either way, you get negative 65,535. When we are looking at this next problem here, you'll notice you have an a sub n. So I'm going to choose to use the second formula. So I'm going to plug in my first term. I'm going to plug in my R. I don't know why I wrote R when we know that R is -4. And once again, I said typically put R in parentheses. And then I'm going to plug in what my a sub n is, which is this right here. And then you could just type it in as you see it, or you could type in the whole top in one set of parentheses and hit divide and then put the whole bottom in parentheses. If you would do that, you get negative 39,321. Doesn't make a difference. We also have sigma notation. Just like we did for arithmetic, we have sigma notation for geometric. Now, when we're looking at this, whatever your exponent is on, here's your exponent. Whatever that is on is your R. The number that is in front that's being multiplied by that is always your first term. So we would know that down here, this is your first term, and R is the thing that your exponent's on. And then we can go ahead and work this out. So if we have our first term and we have R, I'm going to go ahead and use this formula here. Now, we had used the formula before where we had another set of parentheses. It does not make a difference which one you choose. They'll both work. So if you plug in your first term, negative 4, plug in your R being negative 4, n is the number of terms, which is typically your top number here. And it's always your top number if you start out at n being 1. You do have to go ahead and use this if you're not starting out with that bottom number being 1. So all we have to do here is put the whole top in one set of parentheses, hit divide, put the whole bottom in parentheses. When we type that in, we get 52,428. So we're going to do the same thing here. Remember, the thing that your exponent's on is R. What's in front, which would really be just a negative 1, is your first term. And this is the number of terms. So we can use our formula. So I'm going to go ahead and use this one here. Now, if we knew our last term, we'd use our bottom formula, but we don't know our last term. So all we're going to do is just type that in, fill stuff in, and then type it into our calculator. Our first term, our R, which we know is negative 2, and type in n, or put in n, and then we could type this into our calculator. You could type in the whole top, divide, type in the whole bottom, but you got to remember to put the whole top and the whole bottom in parentheses, or you could type in the top and the bottom each separate and then divide. Either way, you get negative 43. Over here, remember the thing that has the exponent on is R. What's in front, and you notice there isn't anything in front, so that means it's really timesing by 1. Your first term is this. So then we can go ahead and use our formula, typing in your first term, then going 1 minus R to the n over 1 minus R. Once again, R is 2. The number of terms you're adding together is always going to be that top number if you're starting out at 1. And so then you can type all this into your handy dandy calculator and you get 255. So here we are once again looking for the number of terms. So I want to use the formula that has this, has this, has this, and has this. That happens to be this top formula. The bottom formula has an a sub n, and we're not dealing with any of that. So I'm going to just use that top formula. I'm going to go ahead and plug in my R. I'm going to plug in my S sub n, which goes on the left side, plug in my negative 2, and we don't know what n is. That's what it is we are looking for. So to do this, I'm going to go ahead and when r is positive, we don't really need that extra set of parentheses. So I'm going to just write it like that. On the bottom, if I work that out, you will notice we end up getting -1. So I need to get rid of dividing both sides by -1. So I'm going to times both sides by -1. And you'll notice you get 62 is equal to a 2 times my parentheses. And I'm trying to get n by itself. So now I need to go ahead and get rid of multiplying by 2. So I'm going to divide both sides by 2. I'm just working backwards to try to go ahead and solve this. Now I need to get rid of that 1. So I'm going to subtract a 1 from both sides. Okay, you'll notice I dropped my negative here. So I'm going to put that back in. So then I have to divide by -2. Then I subtract my 1. I get -32 is equal to a -2 to the n. To get rid of this negative here, it's really like a -1 that's being multiplied. I'm going to go ahead and divide both sides by -1. Then I get 32 is equal to 2 to some power. Now, we know n, the number of terms that we're dealing with, has to be a nice normal number. So I just start plugging in some different numbers for n. So I go 2 to different powers. Now, most of you know it's not going to be 2 to the second because you know 2 to the second is 4. I might try 2 to the third. Well, that's 8. If I try 2 to the fourth, that's 16, and I can do that on my calculator. I try 2 to the fifth, and that's 32. So I know my answer is n being 5 because that's the power that when we plug it in there, we end up getting 32. So go ahead, pause the video, read through this. If we look at what we're dealing with here, we're starting out with 35,000. Then we're looking for the next term. And then we're looking for the next term, which would be our third term. And we're getting 4 consecutive pay increases. So it's not saying fourth term because that's pay increase 1, pay increase 2, pay increase 3, pay increase right there. So we're really looking for our fifth term. And we're wondering how much he's going to get paid. So it's not a series because we're not looking for the total that he's getting paid over those 5 years. We're wondering what he's going to be getting paid during that last term. So that's really a sequence. Remember, our formula is this. Our first term is at 35,000. Then we need to plug in R. And then N here is 5 because that's our fifth term we're looking for because we needed to have 4 increases of that. Now, your R, we need to take this, which is a percent, turn it into a decimal, which is a 0.035. You got to move your decimal point 2 spots. Now, R, because it's this much of an increase, that really means it's 1.035 because you got to have your original amount, which is the 1, and you're adding 0.035. So that's your R because it's an increase onto your initial amount. Now, if you just type that into your calculator, and remember you're dealing with dollars, you get $40,163. You're dealing with money, so you need to go to the nearest cent.